Okay, on the mill now. So here you can see the piece. It's pretty nice. Just the way it should be. There seems to be some air bubbles in the casting, but that doesn't matter, it's just fine. So now we're gonna put the piece in the chock of the rotary table. And because I don't want the piece sitting against the chock face like this, I want to get it upper so I don't drill in the chock. So I'm using a lathe tool holder. Under the piece. So there's 25 millimeters between the work and the chock. Now I'll just tighten the chock. Just a little at first. And now pull this out if I can. Yes, I can. And now I'll just tighten it a little more. Okay, the next thing is to dial the piece in. I've disengaged the screw so it turns free, and the table also turns free, like this. Let's see it or not. There's quite a bit of runout, about 0.25 millimeters, which I think is about 10 thousandths for you American guys. Okay, let's make it turn a little better. And this will be done by moving the chock on the table. And that will be done by untightening these bolts. Just a little, not much. And then we will find the high point. Which is here. Okay, because the error was about 0.25 millimeters, we have to tap the chock about 0.13 millimeters. And this is done by tapping the chock backplate, not the rotary table here. Let's see what happens. Should be around there. Now we tighten the knots and see what we got. Pretty close. Maybe about 700, which is a little over 2000. Let's make it a little better still. Let's find the high point again, which is here. Just a few, maybe 200 now. which is here. Okay, let's see again. That's about 600, which is very close to 2000s. Could be a little better, but for this job it's very good. Okay, now we have to find the center of the piece, so that the center is the same as the machine's center. And this is done by attaching the dial indicator to the spindle of the mill, like this. I've just eyeball it for now. Let's see what the needle shows us. It's going like crazy, so we are very far off. Okay, first let's do this axle. So here it's showing about 0.5 on the smaller needle, and when we move it 180 degrees, it shows about 4.5. Okay, let's turn it again so we can see it better. About here. So 4.5 minus 0.5, it's 4 millimeters. So we need to move the table 2 millimeters. Let's do that. Should be better now. Let's see. Yes, looking very good already. So it shows about, stupid autofocus. It shows about 10 there. And here it's about 45. So let's move it here again. Just a little more. Maybe that much. And we are very close now. 0.1 millimeter is the accuracy I'm looking for. Here it shows 20, 25, a little over 30. So the other axis is still a little off. Let's do something about that. Just a little, maybe 500. Oops, a little too much. That's okay. Let's see again. And there we have it, I think. It's about maybe 200 or 300, which is very good. Okay, and because the diameter of the hole pattern is 65 millimeters, the radius is 32.5. Which is here. So this is how much we need to offset the piece to drill the hole pattern. And this is done by moving the table to one side or to the other. But the first thing to do is to lock the table in this axis. And then let's move the table 32.5 millimeters. This axis is already zeroed. One turn is 6 millimeters. So we need 5 and a little more turns. Here we go. 6, 12, 18, 24, 30, 31, 32 and a half, which is right here. And this is where I'm gonna lock the gips. Before drilling, I have to chamfer the piece a little, which will be done by using a 12 millimeter solid carbide end mill. The first thing to do is to engage the screw again, like this. Let's see. Here we go, and then we'll lock it. And now the table turns by rotating the lever. First, let's bring this table to 0. A little oily and greasy. 0 is this way. This is 90 to 1, so it's a little slowed. Here we have our 0. Now let's do some math. Okay, because we want 8 holes, we take a full 360 and divide it by the number of holes, like this, which gives 45 degrees between the holes. So the first hole will be at 0, the second at 45, 90, 135 and so on. Very simple. For example, if you wanted 5 holes, it would be a little different. Let's try it out. That's 72. It's very difficult to calculate in your head. So a calculator is very good to have. I will show you the first 2 millings. Let's start the mill. The RPM is about 5 or 600, and feeding will be done by hand. The table is locked, of course. got 0. Okay, there we have it. Until the flange. So now we can zero the dial. Like this. Now for the next hole. Locks off. And 45 degrees is the next one. Here we have it. Locks on again. And here we go. Let's see if we have the right zero. Should be right there. And it also is.